All right, so I want to do 7.3, number 44, which says solve this, right?
Cubic.
Solve each cubic. Okay, so they even warned me, right, that this is a cubic, not a quadratic. So in particular, I can't use the quadratic formula to do the whole thing. Multiplying this together would be a major mistake. Cool? That said, what I would advise you do is say, this is a product of two things, right?
Yeah.
Let me use the zero product rule. So zero product rule, the PR product rule, would say what?
W equals 0.
W0 or
W squared minus 10W equals 0.
W squared minus 10W plus 20 is. It's cool with this? This one's done already, right? That's going to be part of my answer. This one, I got a bit more trouble. What do I do with this one? How do I solve W squared minus 10W plus 20 equals 0? Oh, yeah, that's a quadratic, right? You guys see that? So I could try to complete the square. This is a good candidate for complete the square. I could try to factor. Is that factor? What are you looking for? Two numbers that what and what?
Multiply to 20, add
Mul-
to negative 10.
Multiply to 20, add to negative 10.
No.
That seems inconvenient, right? Okay, so maybe I won't factor. So I'm kind of left with either complete the square or quadratic formula. So you want to complete the square on this one just to, okay. So really, and this is the thing, it doesn't matter how you do this. So if you want to use the quadratic formula, go for it. You just got to solve it somehow. So if I complete the square, what do I do first? Okay, I'll move the 20. So I do minus 20. So I got W squared minus 10W plus blank is minus 20 plus blank. I'll subtract 20 and add blanks to both sides at the same time.
Parentheses blanks.
Okay, so I need parentheses and a minus 20 plus blank, right? And what variable goes here? Okay, W for sure, and then where'd you get minus 5?
Divide by negative 10.
Okay, so we took the negative 10, we divide by 2. Then how do we fill in the blanks?
Square it, which is 25.
Square, so we should get 25 in each of the blanks. And then the reason that I fill in this blank is to check, right? So you might spend a second and FOIL this thing times itself. Hopefully get that thing, right? If you did this right, you will get that thing. So I've got W minus 5 squared is what? W minus 5 squared was what? 5. Okay, then what? Yeah, so now I'm done with complete the square, so I'm running extraction of roots. So I do plus minus square root. What do I get? W minus 5 is plus or minus square root of 5. Cool. Then what?
You subtract 5. Or add the 5, sorry.
Subtract negative 5.
Yeah.
Add 5. We can subtract negative 5, that's fine. Right? It works, they're the same thing. So I've got W is
Plus or minus the square root of 5.
5 plus or minus the square root of 5?
Yeah.
Or plus or minus the square root of 5 plus 5, either way. Cool? All right, so what are my answers? Oh, you're so clever. You went back and got the other one. You guys see that? I thought I was going to get you. Damn it. So your answers are W is 5 plus root 5, or W is 5 minus root 5, right? Or W is 0 from way back at the beginning. The hardest part of these is remembering that first one, right?
Is it like that because it's cubic?
Yeah, it's like that because it's cubic.
So that's 3.
That's exactly something we call the fundamental theorem of algebra. That a polynomial with a, so if I multiply this out, this has a highest power of 3, right? That means it has up to 3 roots. In fact, if I allow complex numbers, it does have 3 roots. That's true of really whatever powers. So if you write down a polynomial, just a bunch of w's added together with powers on them, whatever the highest power is will be how many roots you get. It's very cool. It makes solving polynomials really predictable. There's a really cool thing called Newton's method that does this using a little bit of calculus, but that's how a computer does it. And it knows when to stop because there's only so many, right? Cool. Questions on this?
What would that look like on a graph?
Oh, good question. What would that look like on a graph? So let's see. What do I know about these things? See, so this thing, right?
Right in
This is a cubic, right? So I might think to myself, cubics look like this, right? They're like a little whoopty thing. And then this is, when does it hit the x-axis, right? Okay, so here's my picture. And this is only ballpark, right? But it hits the x-axis, sorry, not x-axis, what's the inputs in my function here?
W.
W's, right? So it hits the W axis at 0. Whatever 5 plus root 5 is and whatever 5 minus root 5 is. Ballpark, how big is root 5?
2.5.
Yeah, 2 point something, right?
Yeah.
A little bit bigger than 2. So
2.2.
this is about, this is a little bit smaller maybe than 3. So ballpark there-ish, right? I'm doing ballpark because I have crappy drawing skills. And the other one is ballpark a little bigger than 7. So there's 5, 6, 7, a little bigger. So I need a whoopty that goes through all 3 of these, right?
Pretty cool.
You guys see that? So this is what the cubic, this guy looks like. It looks just like that. And we could do some shifting rules to, we could talk about shifting rules a little bit here. It's a little harder to do that with cubics, but it's there. Cool? Good question.